My name is Tom Pankratz. I'm a former director of the IDA and the editor of the Water Desalination Report. The IDA is a technical trade organization with a goal of encouraging research, development, and the appropriate utilization of desalination and water reuse technologies. Today's IDA represents the coming together of two organizations in the 1980s, the International Desalination and Environmental Association and the National Water Supply and Improvement Association. Today we're in San Diego at the IDA's biannual World Congress, where we're going to be interviewing some desal industry veterans. This is part of a program funded by Faith Leitner in honor of her late father, Gordon Leitner, an industry veteran and a mentor to many of us. Gordon was a former IDA president and the founding editor of the organization's Desal and Water Reuse Quarterly. Today we're going to visit with two thermal desal pioneers. On my left is Danny Hoffman from Israel, and next to Danny is Gerard Canton with CDEM in France. Actually, it's Veolia CDEM, isn't it?
Yes.
So with that, I'd like to start by asking you, Danny, if you could just quickly tell us how did you get into desal? What caused you to get into the industry? And then just briefly tell us the affiliations that you had and the approximate years so we can help put this in perspective.
I joined a company called Israel Desalination Plants in 1963, October 1963. And it was just an answering to an ad in the papers. And prior to that, I'd worked with companies in the United States. I got my 2 engineering degrees in mechanical engineering at United States universities. The first bachelor's at Cooper Union of New York, and the second at University of Southern California, the master's. And after that, I worked with some very large companies in the defense industries, and that taught me a lesson. There are 2 things I didn't want to do. I didn't want to work for big companies where there were thousands of engineers and you could look ahead and see where you'd be in 5 years, and 10 years, and 20 years, etc. And of course, all the politics over there. I didn't see any future in that. The second thing I didn't want to do is I didn't want to specialize. I wanted to be a generalist. And the reason for that is because technology was changing so quickly that you ended up being the specialist of the left bolt on the right wing, and pretty soon they didn't even need airplanes. They were using missiles and you were out of a job. All your specialization was out. So I wanted to be a generalist. Anyway, I came to Israel because my father asked me to come and join his business. That didn't work out too well. And I decided before I returned to the United States, I'd try to look for a job regularly. And I answered an ad, and I found a very young company with really select people. Each one of them was top-notch engineer, hand-selected, hand-picked. And they were doing exciting things about new processes that were being proposed by an Israeli immigrant from the Soviet Union called Alexander Zarkin, whose name should be remembered also, because even though it's not distillation processes, he was proposing the freeze desalination processes, and it also involves heat transfer, so it's also a thermal process. And I looked over there, and there was really exciting things I was given responsibilities that I think 20 people would have to die in one of the American companies I worked with before I would be given a chance to do it. And I was really thrown into something like sink or swim. And that's how I got into desalination. I started working on the secondary refrigerant freeze desalination process, which was a parallel process to the vacuum freezing, vapor compression freezing process. And it was supposed to extend it to much larger desalination plant capacities, because the vacuum freezing process was limited by the fact that at such low temperatures, the specific volume of vapor is so large that you need huge compressors. And the success of the company resulted from the fact that it developed a unique, lightweight compressor, low-cost compressor that was able to pump huge volumes of vapor across very small pressure differentials. But even this compressor had limitation, and to go to larger plants, you had to use a secondary refrigerant where the specific volume would be much smaller, and you could use conventional compressors, which were also much more efficient. And so I was developing this process while other people from the company, I'd like to mention some names later on, if you'll give me a chance, they will continue working on the vacuum freezing process. But it was really an exciting adventures into completely new technologies where even the basic data was unavailable. You had to develop the heat transfer coefficients, how to grow ice crystals, et cetera, et cetera.
Now, you said Israel Desalination Plants, that's IDP, but yet a lot of your career was at IDE. Help us understand that.
Okay, a lot of politics involved in that. Originally, the idea to develop the freeze desalination process to materialize Alexander Zarkin's ideas started only when an American company showed interest in it. It was called Fairbanks Whitney or Fairbanks Morse, later purchased by Colt Industries. And they also had similar ideas with a guy whose name is worth mentioning, called Bruce Cox, who also claimed to have thought about the same idea. Now, the beauty of this whole desalination process was the fact that it was operating near the triple point, and basically it involved only the transfer of latent heats. And basically the latent heats were being recycled, so there's really the only energy input you had to put into these processes were actually just to overcome the irreversibilities. You had to have some delta T's, driving forces, to have all these processes carry through. But basically the heat that you had to take away from the water in order to freeze some ice is the heat that later on, after you pumped it through the compressor, you used to melt the ice. Both the vapor that condensed and the ice that melted were both free of salts. So in any case, Fairbanks Whitney was very much interested in this process, and we worked on it for many years. And some of the guys that are worth mentioning from our American partners are people like Dick Bridge, Richard Bridge, and Paul Weiss, and Wally Johnson. I mentioned Bruce Cox, and of course Dieter Emmerman, who died just a few weeks ago, who was also working on heat transfer and on the compressor. So basically we had to really develop the original numbers, to know how to carry this process through. It was very exciting times, a lot of R&D.
So it was IDP,
but later on, Colt Industries decided that there was really no future. Just about the same time that in Israel, we also decided it was a beautiful process thermodynamically, but it was a little bit too complicated. We look at the markets for plants in the size of 200 to 1,000 cubic meters per day, which is about the limit of the compressor for the vacuum freezing process. It was a little bit too complicated to sell to the market, which was mostly hotels and small towns, remote places where the alternative to desalination was laying out long pipelines or carrying water over long distances. In other words, desalination had a place only where the cost of the desalinated water was cheaper than the alternatives. Mm-hmm. And in those places, they didn't have the technical people to handle such a process. We had to look for something much simpler, which is why we eventually left the ice and just kept the vapor compression and went into the low temperature vapor compression processes.
Okay, and then
what the company did, the government did, is they tried to ease Alexander Zarkin out, and after the Colt Industries lost interest in it, they formed a company specifically to develop the next generation of plants based on a lot of the know-how and using the same people who gained know-how and experience with the vacuum freezing, and just took the vapor compression evaporation part of the vacuum freezing vapor compression process without the ice, raising it not at close to -5, -3.5 degrees centigrade, but at ambient temperatures, and to see if the compressor now does not have the contribution of the desalinated water from the ice, but just from the vapor. But at such temperatures, such as room temperatures, the specific volume of the vapor would be much smaller. Therefore, the compressor could pump much larger amounts of water mass-wise. And therefore, we wanted to see what we can do with it, provided the compressor could handle the much higher pressures. And that's why we had to go through another development stage to see how the compressor can work at such conditions. And of course, there was a lot of advantages for that, because at ambient temperatures, the whole feed exchanges were much smaller. We didn't have to have makeup heat in order to read just the inefficiency of the process. If you recover it through heat exchanges from the outgoing streams, you could actually maintain thermal balance and operate it. You didn't have to insulate anything. You could use much lower grade and lower cost heat transfer materials like aluminum. You could use plain low-cost carbon steel epoxy painting. And as I said, no insulation, not on the pipes, not on the plant. At ambient temperatures, a lot of advantages to this thing. And the aluminum alloy costs about a third of what a copper nickel alloy, maybe a fifth of what titanium. We could be generous to heat transfer surfaces, therefore we could put much more heat transfer area, reduce the thermal driving forces, which corresponded to the delta P that the compressor had to operate in. And we got into a line of vapor compression plants with very low energy consumption. To come back, this company was IDE, Israel Desalination Engineering, which did not have Alexander Zarkand as a partner and did not have Colt Industries as a partner.
No, and I certainly want to talk about some of these technologies here, but I just wanted to draw that distinction to a lot of companies who aren't familiar with it. So ID Israeli desalination plants was basically the Zarkand process,
right.
And once they moved on and started to get into the mechanical vapor compression,
and later on
it became IDE. And you
but
continued.
But it remained a government-owned company with its own limitations and advantages. The advantages of being a government-owned company, but there's a lot of disadvantages. And of course, the whole idea was to develop a process that could solve Israel's long-range water problems, larger plants that could give a solution to Israel's water problems.
And you were with them until 85?
1985.
And in a number of positions?
I started out for 4 years. I was R&D man in charge of the pilot plant developing the Zarkand secondary refrigerant desalination process. Then I was appointed the marketing manager. And my first job was, of course, to try to commercialize all the processes that were developed by the engineers at IDE, which was the low temperature vapor compression, mechanical vapor compression. Then when we went into much larger plants, we even omitted the compressor and went into multi-effect vapor compression, multi-effect distillation, and also multi-effect thermal vapor compression, because we had many applications where we had to replace multi-stage flash. In other words, the joining into a cogeneration plant with electricity was such that the steam was available from the turbine at pressures of maybe 1.5 to 2 atmosphere, whereas we only needed 0.3, 0.4, meaning very low grade and low cost steam. But where the steam was available only at that pressure, we use an ejector, a thermal compressor, to recycle some of the vapor and increase the economy ratio of the desalination plants.
Okay. Well, let's move to you, Gerard. Give us a brief background on how did you get in this industry, and what have you done while you've been in it?
Okay, well, compared to Danny, I'm a newcomer, if I could say. I was graduating from the French Navy shipbuilding school of engineer, and when I was in the school, we had to make an internship at the beginning of the school. Well, at the second year of the school, and I had a nice small paper saying that a company called CDEM is looking for 2 guys to be trained in Abu Dhabi, and so I started like this in '78. I went to Abu Dhabi in Abu Dhabi power station. It was a MSF plant of 5 MIGD each, and we had 3 plants, and so I started like this. And then the next year I joined CDEM, and they asked me to make a study about a single MED plant of 250,000 cubic meter per day, to see if it was possible to do such a big plant. And so at that time, CDEM was still engaged in MSF, but also was developing MED, but at small range at that time. The biggest MED at that time was 1,500 cubic meter per day. So the result of our study at that time was no, it's not possible actually the state of the art for the MED, but it was possible for MSF, which has been nearly now we have a MSF plant of 22 MIGD, so it's we can see that we can develop this. But then I see them. So see them. They asked me to work for them. So which I did. So I never looked for a job in my life because now I'm still with CDEM, and I'm now. I started as a process engineer. Then I was in charge of the small industrial unit department, dealing only with MED, with thermal vapor compression or mechanical vapor compression. Then I moved to the Caribbean, where I stayed for 10 years, and I was in charge of the sales activity of CDEM in the Caribbean. This is where I start to compete with IDE on different locations, like in Curacao, in the U.S. Virgin Islands, in Mexico, and started also to compete with Aquachem, with yourself.
Yeah, it was
at some stage.
It was tough business competing against both of you guys.
And so in the Caribbean, I created a small operating company, which is called UGDEM, Caribbean Union for Seawater Desalination.
And you started that company for CDEM. I mean, this was
for CDEM,
yes.
yes, for CDEM. I created this company in 1984, and this company is still existing, and I'm still the chairman and CEO of this company, and so that's the reason I'm still. I have good. I like very much to spend some time in the Caribbean. I married myself over there. My children, they are born there, so I have a long history with the Caribbean. And then I moved back to CDEM after 10 years to take the sales, to be the sales director of CDEM, which I have been sales director of CDEM since 1994. And then in 2002, I became deputy managing director in charge of sales activity and projects, which I'm still doing this for CDEM. And I would say one of the biggest achievements of CDEM during the last years is that we succeed through the IWPP scheme to impose the MED at a larger scale in the Middle East. And now we are right now starting erection of Azure North Phase 1 in Kuwait with a MED plant of 10.7 MIGD each.
Well, it's interesting. As we talked before we started this interview process, we reviewed the fact that we all competed against each other, although we didn't really know each other. I mean, those were different times, some years ago. In fact, that was the very start of my career, and I was a young guy. But even the two of you didn't meet each other during that time, even though you're competing in the Caribbean very heavily. I mean, things are a lot different now with these international conferences all the time. But tell me a little bit about the competitive nature of the two companies, because you certainly, between IDE, I say you, Danny, I realize now you're an independent consultant, and the Israeli government is one.
No, I work for a private consulting company called Adan Technical and Economic Services, but we are doing jobs for the Israeli Water Authority, the Israeli government, and also to private clients.
Okay. Well, I guess, yeah, that was, when I said independent, that may not have been the right characterization. But you're a private consultant now.
Right.
But so if we, so the times have changed, but let's talk a little bit about when you were with IDE and during those 60s, 70s, 80s. What was it like? I mean, how did you look upon the competitors?
Well, we didn't actually. There was a very strange situation. 90% of the world market for desalination, and at that time, desalination was only thermal. Reverse osmosis didn't exist. Electrodialysis was suitable only for brackish water, marginal waters. And 90% of this market was in the Arab countries, Arab world, that boycotted Israel. So most of the companies like Sidem, and I can mention a lot of companies, we're Westgard, Ayton of England, Krupp of Germany, they were all running to these very lucrative Middle Eastern markets where we couldn't. And over there, energy costs were considerably lower, and there was really no incentive for them to design efficient plant. The only thing they wanted was maybe to, and therefore a lot of, to save in capital costs. Therefore, most of the plants you saw at that time was 6-to-1 economy ratio, 8-to-1 was the top. There was really no incentive to save on energy when the internal cost of energy was something like $2 a barrel, while they were selling it to the world market for $40 a barrel. Whereas we competed in areas where the price of energy was very expensive, and we were driven by the market to develop very efficient plants that could use low-grade energy, low-temperature energy, waste heat, and our vapor compression plants also reduced energy consumption to about 8 to 10 kilowatt hours, which was unbelievable, because at that time the competing vapor compression plants were using 18 kilowatt hours per cubic meter, and maybe plus makeup heat to raise the water to the temperatures above 100 degrees centigrade, where they could use much smaller vapor compressors. So we were really driven and to these other markets which were very difficult. I often used to say to people, anyone who can sell desalination plants in these markets can sell anything anywhere in the world. It was a very difficult and competitive market, a very small market with a lot of politics and etc. But we succeeded because most of our clients, at least for the smaller plants, were private people. We didn't have to do with all the hassle of government committees and government politics. And these people were concerned only with one thing: what is the bottom line? What is the cost per cubic meter? And we had an answer that nobody else could do. We didn't run into our competitors because they were picking the oranges in the low branches where it was much easier picking. We had to climb all the way to the top, to the 10% of the market that was open to us. And that really drove us to develop really very, very efficient plants. And so I never met my colleagues, except at international meetings where we used to sit together at the bar and tell jokes for about 3 hours, including people from Aquachem. I don't remember the people from Sidem, but I used to have a very good relation with the people from Aquachem.
Myself, I remember Tommy Lewy from ID, because he used to visit me in the Caribbean at that time, from time to time, saying, "Okay, where do we fight now?"
Well,
I don't fight anymore. Maybe ID fights with you, but not
yeah,
me.
But
No.
Gerard, and what's your perspective on that? Because really, you when you say that they were picking the low-hanging fruit, IDE had remarkable success in the UAE, but not necessarily in Saudi Arabia or a lot of the other Middle East markets until recently.
UAE? No, we didn't say.
No, I'm sorry, CDEM. CDEM was very active, especially in Abu Dhabi, I guess.
No, we were quite successful, even in Saudi. At that time, I remember in 1979, at that Al-Khobar Phase 2 was one of the biggest desalination plant in Saudi. But I jump on what Danny was saying. It was also about the same within CDEM. The founder of CDEM, Bernard Franklin, who is graduated from the same school of naval engineering, very quickly in the second half of the 60s, he realized that MSF is a costly process and not so efficient. And at that time, we had a small division within CDEM, which was manufacturing small MED for naval ship, for oil tanker and things like this. But at that time, those MED, they were with submerged tubes, which was not so efficient. And he decided to go through the spraying system, and we start to develop this. And we start to develop our own thermal vapor compressor. And that's the reason we were competing against ID, because those machines, in the Middle East, they were not interested by those machines. They were looking for very big plant, and so MSF was still the best solution for them. And so that's the reason we were also competing with the IDE in the non-Arab worlds, like Caribbean, Central America, and things like this. And I would say that then in the late 80s, we were selling more MED than MSF. And the last MSF sold by CIDEM, I sold it, and it was in Curaçao for Isla Refineria against Aquachem. It is the last MSF sold by CIDEM.
I didn't realize that.
And then we completely closed the MSF department, and I think that Dr. Laborie, she can still design MSF, but she's the only one within CIDEM now able to do so.
You can say something?
Yes, I was gonna say, I think what happened over here is that the first project that we came in with the multi-effect distillation plant was in the United States Virgin Islands. We sold 3 plants of about 4,000 cubic meters per day each, and they were a terrific success. And I have to tell you that one of the problems we had, at least, trying to sell desalination plants in the beginning was there was a general distrust of desalination in the area. Before we had to sell our unique designs, because they were really unique. There were about 13, 14 people selling multi-stage flash plants, and everyone was operating at top temperatures. And here comes a small company and said, no, we're going to low temperatures. And we had reasons to back all this thing, but they said, if it is so good, how come there's no one else that is going in there? But at any rate, we did introduce the first plants in the United Virgin Islands, and in spite of all the bad name that some plants gave to desalination, they worked fantastically from the beginning. And slowly, I think this started the breakaway from multi-stage flash, because a lot of people started looking at the fact that these plants were working extremely well in the Caribbean. And we started selling additional plants, and we sold dozens of plants also in South America, in the other Caribbeans, in Curaçao, for example.
In India.
India is much later. We're talking about the 60s, 80s. We sold a lot of plants, and at that time, a lot of people started looking at multi-effect distillation, because up to that point, most of the multi-effect plants were long tube vertical, and it was a big disaster by Envirogenics that preceded our plants in the Virgin Islands. Therefore, people didn't want to hear about desalination, and slowly we gave a good name. And I think the news got back to the Middle East and said, well, we can't get Israeli plants into the Middle East, but let's try to find other companies that could use this technology, because obviously it's working very well in the Caribbean. It's much more economical, and I think this opened the door for CIDEM and maybe other companies to go with a multi-effect distillation, which slowly replaced, because you have to understand, multi-stage flash plants, just the recirculation of the water is 3.5 to 4 kilowatt hours per cubic meter. In other words, more than the whole seawater reverse osmosis plants take today in the same, not to count all the heat costs going into it. It was a very expensive plant compared to the multi-effect distillation plants that for passing small amounts of water in these films required maybe 0.8 kilowatt hours, another about 0.5 to 0.3, 7 kilowatt hours per seawater pumping and brine discharge, etc., about 1.2. And everyone could see that that this clearly was a more efficient plant. And I think slowly companies like CIDEM in the 95% of the world market slowly started introducing the multi-effect distillation plant, which is right. At that time, the only large plants were the multi-stage flash, but slowly companies like CIDEM, even IDE after us, started building larger and larger multi-effect distillation plants, and I still think this is the way to go.
But I remember that we started to sell our small MED plant in the Middle East, but for general contractor, for civil contractor, for the life compound, and because it was much cheaper than MSF and much easier to operate. This is the way we managed to introduce the MED in the Middle East. Then we managed in the remote areas, as Danny was saying. It was a perfect product because you don't need high-skilled operators. It's very easy. It's like a scooter. An MED, it's like a scooter. you started an MED like a scooter. So it was perfect for remote areas and so on. And this is the way we managed to penetrate the market. And frankly speaking, at that time, okay, ID was not in a position to sell in the Middle East, but the other company who was doing MED was Sasakura.
Right.
Sasakura at that time, they had developed also same kind of range of MED units like IDE, CDEM. We were between 200 cubic meter per day up to 1500 cubic meter per day. But the two companies which were able to give the golden letters to MED are definitely IDE and CDEM. And because these are the two companies which strongly believe in MED at a period where nobody else was thinking about this. Look, Doosan, they came very recently to MED, and otherwise nobody else.
Danny, you have something to say?
Yes, I think that MED hasn't really utilized its full potential. Because I look at all the plants that CIDEM is selling in the Middle East, in Sasakura also, they're all using thermal compressors. In other words, they're still using high pressure, high value steam. The whole idea of IDEs, multi-effect distillation plants, was to use this low temperature, top brine temperatures of 70 degrees centigrade, maybe pushing it up 75, 80, which means it could be expanded much further in the turbines to produce additional electricity. Its penalty on the electric power station were much smaller, and therefore the cost per ton of steam was much lower as it came out of the turbine at much lower pressure of 0.4 compared to 1.2, 1.4 atmospheres. And therefore, if you gave him the same performance economy ratio, 8:1, 9:1, even 10:1, with such low pressure steam, you had a really much potential, but it's not being used in many places. The only place that we walked in that tried to make potential of it was in Curaçao, where we had to replace a multi-stage flash plant, 10,000 cubic meters per day, that was taking out extraction steam from a turbine at something like 2.3 atmospheres absolute, or 1.3 gauge. And they said, this is the amount of steam we have. So we put in between them an industrial steam turbine and generator and produced about 3 or 4 megawatts of electricity from the steam before we introduced it into our
And CDEM
plants.
made that decision and did that?
I don't know if CDEM did it, but as a result...
Excuse me, CDEM. I keep saying, I mean IDE.
IDE.
You made the decision to put that...
We made the decision, and we bought the turbine, found the right turbine, and as a result, when you give the desalinated water the credit for the electricity that you produced from this thing, it brought the price of the water much lower, and if CIDEM competed with us, they could not compete with it. We had a clear advantage. And I think until today in the Middle East, in Sakura's plants and in CIDEM plants, they're still using mostly thermal compressor, which improves the economy ratio, but still uses high-grade steam from the turbine that penalizes power production.
No, Danny, no, because we did exactly the same plant in Curaçao. We have one plant which is using steam at 1.5 bar gauge, producing 3.5 megawatt through Alstom turbine, and then going to an MED which is producing 12,000 ton.
At what top brine temperature?
67.
Okay, so they adopted the same approach that we had, but this was only after we introduced it in the first plant in the Curaçao. Yeah. So we started with this idea, and they realized the potential. And I don't think that potential is being used in the Middle East yet. So
No,
I think
not yet, and this is what we are pushing right now. I'm pushing since 15 years to tell them, okay, instead of using the steam at 2.7 or 2.9 bar, which is the case in the Middle East, but this is very often this is the specification by the customer, because they would like to keep it open also for MSF. MSF, they cannot go like us at 0.3 or 0.4 bar absolute. They cannot go.
They cannot, absolutely.
Well, if you're bidding an IWPP, couldn't you take that approach? Or do the specifications still prevent you?
We try, and we did it. We did it sometime. You
have to understand, there's a lot of resistance to new ideas. There's a
Well-
whole generation of engineers that went to universities in Glasgow, Scotland, learning MSF, and suddenly they're going to be without a job because there's not going to be any MSF plants around. There's a lot of resistance to new ideas and new things. But if people who are making decisions will get the senses together, I think they'll go in this approach to use low-grade, because everybody looks at the energy reduction of the seawater reverse osmosis plants, but it's a low energy consumption at a very high priced energy, which is electric power. And if they could use low-grade steam or low-grade heat, it'll be great. We sold a plant in the Marshall Islands, eBay, to the United States government, incidentally, that put it over there that used only waste heat from diesel generators, not only from the cooling water, but also from the oil and from the stack coming out. And we produce twice as much of water per amount of megawatts generated by the diesel generator than our closest competitor. And just using waste heat. And it's not being pursued sufficiently. I think they've buried thermal desalination too early instead of pushing it to use low-grade waste heat, low-cost heat.
And this is also, I attended a conference some weeks ago in Martinique, and we were speaking about geothermal energy. And this is a low-cost energy, but low temperature as well, because you have hot water at 100 degrees C. Mm-hmm. And both ID or CDEM, we can use this through our pure MED system. And so I remember we convinced the people there that there is a very cheap solution to make desalination, and it's much cheaper than RO in that case. If you use the geothermal energy together with a pure MED, you can beat every system.
When was the last time CDEM sold a straight or pure MED?
The last time was in Curacao. 10 years ago.
10 years ago.
10 years ago. But when you are making a high performance ratio MED TVC, you can make a high performance ratio pure MED. It's simple to make a pure MED than a MED TVC.
Yeah, it's a higher economy ratio, but with higher pressure steam. Okay. Let me ask you, what was the economy ratio of your pure MED plants that you sold without
10.
the thermal? 10 to 1?
10 to 1.
And using what heat transfer material?
Copper nickel.
Copper nickel. Okay,
aluminum brass.
Aluminum brass. Okay, so you also came down in cost. But the point is, we use this low-cost aluminum alloy, which didn't really require initially removing air, because the fact that you had a little air and only meant if you had a good NCG, non-condensable gases removal system, it didn't interfere with condensation. But you weren't afraid of corrosion so much because the aluminum formed an oxide, which was a protective oxide. And because it was such a low-cost material, we were able to use for marginal cost, much larger heat transfer surfaces, and therefore reduce the delta T on each effect, and with a low top brine temperature, produce a very high economy ratio. This was the advantage.
And I don't disagree with you, clearly, but that was something that Aquachem, that's how they sold against IDE, the fact that they use these low-cost, cheap aluminum tubes. And CDEM did too.
Because the clients were sold by consultants who told them, what Aquachem tried to do is try to tell everyone that IDE was selling cheap plants because they're using cheap materials, as if the objective of the desalination designers was to design expensive desalination materials with Cadillacs and chrome and gold-plated whatnot. The whole idea was to use to design the plant in a material that was cheap and can still operate continuously. The plant that we sold in the Virgin Islands worked for 30 years. And what people thought it won't work for 10 years or 5 years because of 30 years. And the fact is, we didn't have the aluminum tubes brazed in over there, but it was in rubber grommets. You could slip it in and slip it out and replace. The whole seawater reverse osmosis industry is based on membranes that the cost per kilogram of material is maybe a couple of dollars, but they sell a membrane for $500, $600. But the cost of the material in it is maybe a few dollars. So why does anyone say that's a cheap material? The whole idea was to use as cheap as possible. The bottom line, as long as it worked reliably, and it was designed for low temperature and could work at low temperatures. What was wrong with using cheap materials? On the contrary, we used plastics in many places because the plastic could tolerate these temperatures. You didn't have to worry about corrosion. So the fact that Aquachem accused us of using cheap materials was completely wrong. The idea is what would the plant cost and does it work reliably? And we convinced the clients. As a matter of fact, one of the main jobs that we had over there, and I can take a little bit credit to it, is that we almost didn't advertise. We took all our money, marketing money, and we put it in on service to the client. In other words, our main concern, the plant had to work. So if we had means sending our technicians 3 times, we send it even if the client didn't pay, make sure that the plant is working. And then when we had to sell someone, we used to take a client to see one of our plants, and the man over there who bought the plant maybe won't say thank you if he saw that he got 10% higher performance, but if the plant wouldn't have worked or would have given him 1% less performance than we promised, he would curse us forever. But in his heart, he knew that we gave him a good plant, and so we invested in services, in servicing the plants, and our plants worked everywhere. And so we had a reputation that our plants work. So what difference does it make what material we give?
Okay, I understand. Let me ask one question. You mentioned earlier the Marshall Islands, where you sold a unit to the U.S. government. Were you involved in the Gitmo project?
No,
okay.
I was not.
Okay. I asked that because that was another thing that the fact that that IDE received a couple orders with the U.S. government was a particularly sore spot with with Aquachem.
I know, and in fact, the United States was probably the first country in the world when it came to trade. I could never sell a plant in a French territory in the Caribbean like Martinique against CIDEM. Never I could. And maybe in Spain I couldn't also sell against Babcock Wilcox. But the United States had an open mind. If something worked and it was good, the United States accepted it. That's why the economy looks the way it is. If someone has a good idea, they don't care if it came from Timbuktu. They take it, adapt it, and everything is top-notch, frontline, cutting-edge technology in the United States. And it paid for itself. We competed with a company that gave a performance half the amount of desalinated water from the amount of heat that is available from the diesel engine than we gave. And we gave a good price. Everybody won from it. And I remembered it. And whenever I could help U.S. commercial interests, I helped them as well, because I remembered it.
Let me ask Gerard a question about Abu Dhabi. You were so successful, or CIDEM was so successful in Abu Dhabi of all the Middle East. Now since, in fact, when you and I worked together later when I went to Veolia with CIDEM, we went and did some work together in Saudi Arabia, but it took much longer to get some CIDEM installations, MEDs in Saudi Arabia or Dubai, or why Abu Dhabi? What did you do that was that led you to be so successful in Abu Dhabi?
Because they were quite open. They were quite open for MED, but for the remote area, they had a department at that time at the WED, Water and Electricity Department of Abu Dhabi, which was the company before Adwea. And they had a department inside, which was a remote island and village. And for this, we convinced them that the MED was the best solution. And they agreed to this, and we managed to sell small MED, and then we managed they were open to new process and improvement. And so we managed to sell a plant of 1 million gallons, and then a plant of 2 million gallons. This is the way we started to raise the capacity of a single MED unit.
And then Taweelah was a turning point?
Abu Dhabi was quite open. I should say that Abu Dhabi was quite open to that, and that's the reason we managed to succeed like this. And then The second country where we were quite successful with MED was in Qatar as well. In Qatar as well, they were quite open with MED, and we managed to sell some pure MED to Qatar, also 1 million gallons each. So it was also a good success. And then in Saudi, when they started IWPP, okay,
then that changed the game.
It was a door open for MED because it was, as Danny was saying, if you compare MSF and MED on a pure economical point of view, there is no game. MED will always win, always.
I'd like to see if there's anybody in particular you'd like to remember, any project that stands out, a turning point that.
I'm glad you asked that, Tom, because I was going to bring it up myself. That I think that it should be mentioned that the whole operation, ID operation, was a team effort. It was a fantastic team of people. It's not Danny Hoffman. I was the front man over the face of ID to many people in the world. But basically, a lot of people stood behind it, and I would really like to mention a few names. Beside Alexander Zarkin, the first general manager was Jacob Adari. I only worked under him for 3 months, but after him came Abraham Pellet, the military man, who put some order in this company. These wild people with crazy ideas, working in the laboratory and in pilot plants and whatnot, and made it into a company. Nathan Berkman, the eternal optimist who believed in the plant when everybody's mood came down, and there was some difficult times for a while. People like Ami Barak and Dr. Aryeh Golan, who really came up with the idea of doing away with the ice and using the compressor itself for low temperature vapor compression should be mentioned. People like Dr. Uri Fisher, who worked on the compressor and improved its efficiency completely. Abraham Ophir, who helped improve the reliability of the compressor, which was huge, with large rotating vanes, lightweight rotating vanes.
Now that's a name that's well known.
Abraham
He was there
Ophir,
many years.
Of course. Shlomo Ophir, people like Abraham Koren and a few other people, and also a technician. We had a fantastic team of technicians who went all over the world and made those plants work no matter what, and they had improvised. Some of these technicians, actually, I look at them, they would have made fantastic engineers if they had the opportunity to go to college and learn, but some of them went through difficult times and never had the chance, but they also deserve credit for it. As far as projects, I think several projects stand in mind. I mentioned one of them before, which is the United States Virgin Islands, which opened the Caribbean market to us, because I could bring clients to the Virgin Islands and everybody could see the plants were working. The client was satisfied, and we solved the water problem in the U.S. Virgin Islands, which is also important. And the Curaçao plant was important because I think the idea that later CIDM used of putting a compressor between the main power station and the desalination plant to make use of this delta P to generate additional electricity was an interesting point. There was an interesting project with the United States government to develop this to much larger plants in Ashdod. So the United States put up 20 million, the Israeli government put 20 million, and the benefits were to be shared by both governments to make very large-scale multi-effect distillation plants. I think some of the plants in South America were also very interesting because we went to some very remote places in the jungles that maybe CIDM never heard of, but I had good agents in South America who did what we call the prospection, the 3 phases of desalination: prospection, presentation, and closing. They did prospection, I did the presentation and also the closing. But they looked and found these strange places, and these plants worked in fishing companies in Ecuador, in the coal mine in Cerrejón in Colombia, where the U.S. company Morrison Knudsen was involved with it. And there were several very, very interesting companies. I think the first plant in Eilat of the MED that proved it in the 1 million gallon per day was also very important. And also the first few vapor compression plants that made a name for vapor compression, low temperature vapor compression, are important. I'm sure CIDM also has some very special projects.
What about you, Gerard? What some people and a couple of projects that change things?
Yeah, well, for the people, I have the founders of CIDM. I'm still very close to them, and it's still a big pleasure for me to see them and for lunch or dinner. So I mentioned Bernard Franklin. I need to add also Jean Brissot, Claude Temsté. I'm sure you remember him quite well. Francis Murat. Francis Murat. I'm still going skiing with him every year. So.
And Camillon.
The one
And Jean-Pierre Quémion, who was our resident in Abu Dhabi for 27 years.
the one member of SIDEM that I remember was de Ginsburg. Do you remember him?
Yes, de Gainsbourg. Yes, de
he
Gainsbourg.
He retired, bought a boat, and went around the world in it or something. I always envied him.
I saw him 2 months ago because one of the old engineer of SIDEM retired, and so he came for the party. So these are the names I remember. I remember also some people external from SIDEM, like Brian Todd. I remember we had a corrosion problem with bromine on acid treated MSF plant in Saudi, and I was young engineer, commissioning engineer there, and so he helped me together with Nabil Nada. So I remember guys like this. And otherwise, regarding the projects, I'm basically I'm very proud of the biggest MED plant of Jubail, 800,000 cubic meter per day, which I managed to sell to Suez and Aquapower, and so I'm still very happy with that result. But I'm very happy also with small plant like the one I made in the Caribbean island of St. Barts, where we combine an MED of 1,500 cubic meter per day with a waste solid incinerator, and so with 1.5 ton of waste per day, we are producing 1,500 cubic meter per day of fresh water, of drinking water, and with a performance ratio of 15.6. So I'm very pleased with that plant. That plant is operating since now 15 years. So it's.
I'd like to mention a few names also, if I may. Sure. Two young professors from the Technion who helped us with heat transfer studies, particularly direct contact heat transfers without metallic surfaces. At one time we thought of developing a heat exchanger with bubbles of one liquid going through another one, exchanging heat. One was Professor Samuel Seidman, I'd like to mention, and a Professor Kehat. And I'd like to mention also 3 United States engineers. I used to call them the wonderful W's because their names started with W. One was Bill Williamson, Bruce Watson, and one was actually an Englishman called John Waters. And they had an open mind to our process, and they immediately saw the benefits, whereas others were even afraid to see us because most of the business was in Arab countries. But I still remember Bill Williamson raising the telephone to John Waters. He was at the time in the Bahamas, and say, "Hey, John, how would you like to have a 12.5 to 1 economy ratio plant with a top brine temperature of 70 degrees and requiring electric energy consumption of about 1.3 kilowatt hours per cubic meter?" And John said, "Send him immediately to me." He wasn't a decision maker, but I still remember those 3 W's, and I want to mention them.
A little story for the end. I remember in 1984, when I was in St. Barts to build the first MVC plant for the municipality of St. Barts. At that time, St. Barts was a tiny island.
It still is a tiny.
Still a tiny island, but regarding population, you had maybe 1,500 people living on the island. So one day I received a call, and it was a call from the majordome, the butler of David Rockefeller. At that time, he used to have a nice villa, nice property in St. Barts, and they had a MECO desalination plant for their property, and the MECO was shut down. And they called me and say, "Well, we heard that a desalination expert is on the island in order to build the new plant. Can he come to fix our plant? So I went there, and I fixed the plant. It was not a big issue, and so I had the privilege to have a drink with David Rockefeller at that time.
Well, this industry is full of a lot of surprises. And I want to thank both of you for coming today and sitting with us and talking. I think we've accomplished our goal, and that is to try to archive some of the people and some of the projects and the development of this technology and the industry as a whole. So we appreciate you coming. I've enjoyed the discussion, and thanks again.
Thank you.
Thank you.
Actually, invite us again, because we haven't even started telling our stories.
Yeah, yes. We had
I have
still
a few
lot.
additional stories to tell.
But for the next one, we can exhume some nice story again.
We'll keep doing this. No,
Thank you.
It's been
Thank
very
you.
good to have you.
And I'd
come.
like to thank also Mrs. Faith
Leitner
for arranging this thing. I think it's a great idea, and it's a good memorial of a man who deserves to be remembered, of course. So it's a great project, and I thank her.